Dear students, in continuation of acrylic spinning, or you can say the acrylic fiber production, I, Prakash Bidla, Assistant Professor, Textile Technology Department, today discuss the spinning processes of acrylic fiber. Acrylic fiber can be spun by solution spinning process, both the dry spinning process as well as wet spinning process. Acrylic fiber cannot be melt spun because it start to decompose before melting. So that's why some plasticizers are suggested to reduce its melting temperature. Then it is the acrylic polymer, after plasticizing, found to be suitable for melt spinning. And nowadays two more new techniques, or you can say related to the solution spinning, is also popular, but not you can say well accepted all over the world. And this is because of its costlier techniques, you can say, and difficult techniques. So one of the dry jet wet spinning process, and another is gel spinning process. Now come to the point here, and to the level of this subject content, the wet spinning process I will discuss here. In this process, the following steps are involved. First step is preparation of dope, or you can say the preparation of spinning solution. Then spinning is involved the coagulation and fiber formation. And next step and final step is the post spinning operations. Then you can say the toe processing. Toe processing involve washing, drying, crimping, and heat setting, cutting, etc. First, how the dope is prepared. Dimethyl formamide is one of the most widely or commonly used solvent, and other solvents you can also suggest, or you can see in the industry. And these organic solvents may be dimethyl sulfoxide, dimethyl acetamide, or for the wet spinning some new inorganic solvents are also used for that. Inorganic solvents may be sodium thiocyanate, zinc chloride, nitric acid, ethylene carbonate. You can see here the aqueous solution of inorganic solvents are used, and here the sodium thiocyanate, the 45 to 55% concentration of sodium thiocyanate in water is used as a solvent, while the zinc chloride is 55 to 65, and HNO3 is 65 to 75, and pure ethylene carbonate is considered as a good solvent for acrylic polymer. And the polymer concentration is kept for wet spinning by inorganic process. The polymer concentration is kept in the solvent is 10 to 15%, 8 to 12%, or here for ethylene carbonate it is 15 to 18%. Most important point in case of the dope preparation for the wet spinning as well as for the dry spinning, first of all, the solubility and the solution properties are largely depends on the polymer concentration. First of the selection of solvent is very important. It should only dissolve, do not react, faster dissolve, and a DOP with the required viscosity can be obtained, and at high temperature or at low temperature do not you can say create problem in the viscosity of polymer solution, or as well as toward reactivity towards the polymer and solvent interaction. So that's why it is important to select a good solvent. Now, as I told here, just the solubility and the solution properties are largely depends on the polymer composition, and that is polymer composition include the acrylonitrile and co-monomer ratio, in what ratio the polymer is prepared or at the time of polymerization, and also its molecular weight average and the polydisperse value. It is important. These factors decide the solubility and the solvent interaction with the polymer. In case of solution polymerization, the same solution, yes, there are the two methods. There were two methods, as we already discussed in the last video lecture. That was the solutions polymerization process for the acrylic, as well as suspension polymerization for the acrylic. Here, in case of the solution polymerization, the same solution is used directly for spinning, while in case of suspension polymerization, the polymer as produced is dissolved in solvent, and the dissolution of PAN powder in solvent is very delicate process, very important to control the dissolution of PAN in suitable solvent. Here, by the addition of the fine powder of PAN, lump formation may result, and the polymer tend to swell from external side. Externally swelling occurs, and from inside these lumps remain dry and create problem at the time of filtration and at the time of spinning. So therefore, the finely divided PAN polymer powder should be added to the solvent at 0 to 5 degrees centigrade, and the cool mixture is stirred vigorously. Yes, this cool mixture of polymer powder and solvent is vigorously stirred to form a uniform clear suspension. Then this clear uniform suspension is heated to 90 to 100 degrees centigrade and changes into a clear viscous solution. This approach is used for the organic solvent. Yes, it is only for, as I discussed here, only for the organic solvent. When the nitric acid is used as a solvent, then the temperature of the DOP should not be allowed to go above. Yes, the use of nitric acid as a solvent, the temperature should not be increases beyond the -5 degree to avoid the polymer degradation, because nitric acid is highly reactive in nature. So to avoid such degradation, the temperature should be below than you can say -5 degree, and to avoid the discoloration of the acrylic polymers as well. You can understand, means reaction results in discoloration. And now a mixture of some organic additives are also added during the DOP preparation. These mixtures enhance the solubility and the viscosity of the overall final DOP. So here one of the example is a mixture of oxalic acid and malic acid. Yes, mixture of oxalic acid and malic acid by 2% by weight based on polymer is added in the DOP and found an effective stabilizer for the inhibition of the discoloration. By the addition of this mixture, oxalic acid and malic acid, you can see here, inhibit the discoloration. So that's why these are the important to add at the time of DOP preparation. Another important factor which influence the DOP viscosity is the tendency of PAN polymer DOP to gelation. Yes, it as a percentage of polymer is increased, it tends to gel formation. Yes, gel formation is reversible, no doubt, but here create problems because gel may choke the filters. So when the DOP is heated above the specific temperature, this gel melts again and DOP reverts to back its original viscosity. Means gel formation may change the viscosity of the spinning solution. So to avoid such gel formation, the addition of lithium chloride is very important. By addition of 5% lithium chloride, up to 5%, make it possible to prepare a acrylic DOP of with higher concentration. Polymer concentration high can be here in case of wet spinning 8 to 12%, or for dry spinning the polymer concentration is kept 25 to 32%. Okay, thank you.